Okay, so we're going to talk about some types of welders now. The first is oxyacetylene. We won't do much. I'm sure all of you have heard of torch cutting and things like that. It's a similar process, but it's very slow, very painstaking, and very difficult to do well. What we'll be concentrating on is shielded metal arc welding, or SMA, as it's typically called. That just means that you have an electrode, and it has a protective coating on it to shield the metal while you're welding. Tungsten inert gas, we talked about that one, and no, it is not a gorilla. But what tungsten inert gas is, it's a tungsten electrode, and you use a gas to stabilize the weld. If you're interested in this, this is the future of welding, it's been called. And it's very difficult to do, but if you can do it well, your welds are beautiful. Metallic inert gas, MIG welding, sometimes called wire feed. Just have a copper coated electrode and a stabilizing gas. And resistance welding is a spot weld. We don't have any spot welders. It's usually an all-in-one deal, and you just pull the trigger, makes a little weld. They use it for putting car bodies and things like that together. These are some other ones that you don't hear about very often: seam flash butt, electron beam, laser plasma. They have thermite welding, which they use on the railroads to tie tracks together, and that's just like ground up aluminum mixed with something else, but they bind it together. It gets really hot and it creates a weld a railroad track. Basically what welding is fusing two pieces of metal together using heat. And it is very, very hot. At the very tip of that electrode, it's up to 6,500 degrees. And it's enough to melt the metal, so you got to be careful when you're welding so you don't get too much heat on there, because most metal melts around 2,750 degrees. There's a couple of different types of arc welders. We'll be dealing mostly with AC welders, alternating current. These are affectionately called buzz boxes, because they sit there and they the whole time that you're welding. And the benefit of these is they're fairly easy to use, they're readily available, and they're pretty cheap. Don't have much cost to them. The problem with them is a lot of times you're limited to what you can weld because your metal isn't terribly thick that you can accomplish with an AC welder. DC positive and DC negative welders, you can do a lot more. A DC welder uses electric current produced by a generator. And a lot of times you'll see these welders on the back of pickups. You know, they're a one-piece unit. You can go anywhere with them, but they are very, very expensive. They used to only have DC welders, and they were pretty pricey. They still are pretty pricey, and they're a lot bigger. AC welders probably only weigh 50 to 60 pounds. Some of these DC welders can get to like 250, 300 pounds, just because there's a massive copper coil inside of them. These are just the types of arc welders. Two, what you'll find inside, they use a rectifier to convert DC to AC, or AC to DC, whichever you choose. We won't spend too much time talking about polarity, but what that's just saying is whether you use minus or positive, it's either bringing metal up to the electrode or the electrode is going to the metal. And there's a lot of more scientific stuff in there that we don't need to cover. We're mostly covering form and function. Now we're going to go into some welding equipment. An electrode holder is what holds onto the electrode. They're attached to all of those. And a common pair of pliers we'll use quite a bit. What I want to go over now is the difference in your pliers, and your welding gloves should be on here. Maybe not. Does anyone know what you'd use these for?
To protect your hands.
To protect your hands? Anything else? Good. No one said to pick up hot metal. If you pick up hot metal with these, they start to look like this, and pretty soon you've got little elf hands that are all curled up into a little ball. So now we're going to try a little experiment, and I need a volunteer. It's not bad. Brittany. Okay, so I've got this piece of metal here, and I dropped it on the ground. Put on that glove and try to pick it up. If you've got, I'll give you 3 more seconds. I'll let you skip the rest of this class for the rest of the semester if you can pick it up.
No, it's not that.
Okay. Now this is a fairly decent glove, except for it's got one burn hole right here, but other than that it's still pretty soft and flexible. Now see if you can get that piece of metal picked up. There. You see that? Oh, that's alright.
Cheater.
But the point is that these, once they get to this point, they're not useful. You don't have much control of your electrode holder, so it's very, very difficult to get the amount of control that you want to make a really, really good weld. You can pass these around and just feel the fingertips on them. You can try them on. Send that one down to that end. So we want to make sure that we don't ever pick up hot metal with those. That's not their intended purpose. It's to protect your hands from the intense heat and the spark that comes off of those. Now we're going to go over the different shades of lenses. They're pretty stiff.
Yeah, mine have back.
Okay, so when we're arc welding, you will have a minimum shade 10 lens, and that's the darkness. The higher the number, the darker it is. This is a shade 5. This is commonly used for either oxyacetylene welding or oxyacetylene cutting. And if you want to, you can open up the lens on here and look through it just to see the difference. If you hold it up to the light, you can see how much you can see through both of these. And that's just to protect your eyes. It is very, very bright. And if you weld for any period of time without a helmet or with the lens that isn't dark enough, you can damage your eyes and you'll get little burns.
Whoa.
And it won't take long to lose some of your vision or all of your vision, so it's not a good idea at all. This is a chipping hammer, and we talked about this a little bit briefly, but what a chipping hammer does is it removes the slag, or the protective covering from the weld. And you might be wondering why you remove the protective covering from the weld, but if you're going to paint it, you have to remove it, and if you're going to add another weld to that metal, you need to remove it. So it's a good idea to clean up your welds. People say that welding is 90% preparation time and 10% actual welding. So a lot of time will be spent prepping, scrubbing, cleaning the metal before you actually weld. And this one has a brush on it so you can polish it up real nice and get some of those chunks of slag that are in there a little bit deeper. You can use a soapstone, chalk, and we have a little silver pencil somewhere around here. You can use that to mark where you want to weld. If you've got a certain point, you can just put your little scratch on there and then set it there. Let's see. Your grounding clamp is part of your welder. That just completes the circuit. You'll attach that to the table. Now we're going to talk a little bit about protective clothing. So when you're welding, you don't at any time want to not have a pair of safety glasses or a welding helmet on. You might wonder, why do we need safety glasses when we already have a welding helmet? It's because when you're chipping off your slag, it's really difficult to pop that up and see through that screen clearly. So you'll have your safety glasses on, you can take off your helmet and chip off the slag. And the slag is very, very hard and it's very brittle, so it'll fly up and get into your eyes. And then we got to take you to the doctor and get someone to pull it out with a pair of tweezers, and it's not fun. Yeah, it's quite painful. Leather gloves, we talked about how not to use them, how to use them. And if at all possible, you don't want to have cuffs on your sleeves or pants, just because when you're welding, chunks of metal will go down in there and they'll catch in the little cuffs. And then you can burn your hands. But it's also a good idea to wear a long sleeve shirt, just because if there's a gap between, where clothing ends and begins on your gloves, a lot of times you can burn your arms, and I've seen it bad enough to where some people actually get blisters from the heat and light that comes off those welders. And it won't take long. And if you're thinking that it'll give you a tan and you won't have to go to the tanning bed before prom, it won't. It'll just turn your skin bright red. It's the wrong kind of light and it's really bad for you. It's how you get skin cancer. So try to make sure that when we're welding, you always bring long sleeve shirts and always have your gloves on. Leather boots are nice to have. We won't require that you wear actual boots, but at least if you have a good solid top on them. I mean, if you wear your Cinderella shoes or something, you'll get spark in there and you'll burn your feet, and then you'll dance a little bit out there in the shop trying to kick it off. So it's a good idea to have a closed top shoe.
Mr. Center?
Yep.
So like, would my shoes be fine? Like,
Yeah, you'd probably be okay with those. Just as long as you don't wear sandals, like Brittany's got on right now. or anything that's really flammable, like polyester. If you have polyester pants, like I don't know, they probably make them these days, I'm sure they do. But polyester is extremely flammable, and if you get one little bead on there, it'll just melt it, and you'll have a big circle about like that, and it'll burn it to your skin. So try not to wear polyester. It's a safety hazard, and we don't want to have to grab a fire extinguisher. Cotton is best just because it resists flame pretty well, or if you have wool. And wool's kind of itchy, but if you're wearing wool, you're even better off just because it's very flame retardant. Now we're going to go over what electrodes are. I have 6 electrodes here, one for each of you. And there should be little numbers on the side, towards the bottom. There you are. And if you want to read, well, one at a time, read off what it says on there, and then we'll go over it.
7014.
109. 0109.
We'll cover one at a time. So we've got 7014.
Or 6010.
I'm sure.
It's alright. Okay, so we already talked about this a little bit. What do the first two numbers mean?
The pounds.
Pounds. You take that times 1,000. 70 times 1,000 is 70,000. That means you have 70 pounds of tensile strength. Or 70,000 pounds. What that means is it would take 70,000 pounds of force to pull this apart. The higher the number, the stronger the weld will be. How about this number right here, this 1? Any good guesses?
How many times you can use it?
That's actually kind of a funny answer. No. Any guesses, Devin?
No.
Okay. What the number 1 stands for is the welding position. Most of them that you will find is number 1. Number 1 means all positions. You can weld that upside down, horizontal, sideways, inside out. Any position you can think of. You won't find number 2s and number 3s. Number 2 I think is flat only, and I think number 3 is horizontal only. Either that or it's vice versa, one of the two.
What's 0?
The 0?
No.
Oh, 0? I don't think there's a 0. I think there's just 1, 2, and 3.
It's
Flip it
100.
around.
It's,
Oh,
100.
oh, there you go. Yep, you got the tricky one. And how about this last number? No guesses either?
What kind of metal it can weld on?
That's actually a decent guess. But what the 4 stands for is the type of flux. It's the type of coating that is on that. I'm not exactly sure, but I think they go from 1 to 9 on the numbers, and it'll tell you what type of flux coating on that is. Sometimes there's a synthetic coating, sometimes there's a mineral coating. I'm not exactly well versed on that, so we won't talk about it too much. Yeah, Marshall.
I have a 0 for that number.
A 0 for...
For the last number.
Okay. So you've got a 0, and that's 60-10.
Yeah.
So 60-10 would be what?
60,000 or
60,000 pounds.
Okay.
You weld
All
anyway.
positions.
Anyway, and the 0 would be the type of flux coating. Okay, how about you, Brittany?
6011.
60-11. So we've got again 60,000, all welding positions, flux coating number 1. Now there's a tricky one out here somewhere. Okay, what you have?
11018.
Okay, so now we've got 3 numbers at the start.
Wouldn't this be 110,000?
Yep, you hit it right on the button. 110,000 pounds of tensile strength. Position number 1, flux number 8. So that's how you identify those. It's fairly simple once you get used to it. Now there's another thing that you can do with these electrodes. What do you have, Tanner?
6013.
6013. If you're using a DC welder, there's DC positive and DC negative. There's 2 different settings that you can put on that welder. What you have to do sometimes is figure out whether it's plus or negative. And an easy way to do that is you add these last 2 numbers. So we have 4. Let's say this was 12. Then we'd have a 3. If this number is odd, I'll do it this way. This is easier. If this number is even, we have a 2, 4, a 6, or an 8. That's an even number. E corresponds to the letter E. Does anyone know what E means in science? It's a particle.
Electron,
It's an electron. What charge does an electron have?
negative.
Negative. So you use negative on an even number. Anything that's an odd number, use positive. It's an easy way to think of it. Just add the last two numbers. If it's even, it's negative. Odd, positive.
Turn it off.
Yeah.